Today we're going to configure two Linux machines, one as an SSH server and another as SSH client. We will briefly see how SSH password authentication works, and then we'll disable the password authentication method and set up for public key authentication, which does not require username and password to log in. So before we proceed for the setup, let's talk about the theory behind it, and we'll jump into the setup part later. SSH stands for Secure Shell. SSH supports many authentication methods like a login with a username and password, but public key authentication is arguably the most secure and common way of establishing an automated connection to the remote server and administer them using command line interface. So public key authentication provides a cryptographic strength that even extremely long password cannot offer, and users do not have to remember their complicated passwords to log into terminal. It allows users to implement single sign-on, and SSH uses symmetrical encryption, asymmetrical encryption, and hashing techniques at various steps to verify server's identity, authenticate the client, and secure the communication between server and client throughout the session. So now let's look into encryption and hashing technique. So first, encryption is symmetric encryption. I also talked about encryption in my previous video, which I'll put link on the top right corner. So symmetric encryption uses the same key to encrypt and decrypt the message. Each party has their own shared secret with them, which will be generated using a key exchange algorithm. And symmetric keys are used to encrypt the entire communication during an SSH session. Both the client and the server derive the same secret key, and the resultant key is never disclosed to any third party. So what makes this algorithm particularly secure is the fact that the key is never transmitted between the client and server. Instead, server and client share public pieces of data with each other, which they combine with their own private data and independently calculate their own secret key. So the secret key is specific to each SSH session. When one session ends, you'll have to connect again, and it will generate a new session key. So all the communication after the initial client and server handshake is completed, they use a session ID as an encryption key. And there are many symmetrical encryption algorithms, but before establishing a connection, client and server agree on which algorithm to use. Typically, when the client initiates the first connection to connect to the server, it sends the list of supported algorithm in order of its preference. And if the highest preferred algorithm by the client is also present and supported by the server, that's the cipher algorithm they are going to use further. The next is asymmetric encryption. Asymmetric encryption uses public-private key pair to encrypt and decrypt the data. Neither party can decrypt the message with the key that was used to encrypt the message. So for data security, data should always be encrypted with the public key, which can only be decrypted using a paired private key. So public key can be shared freely, but private key should be kept secret and not shared with anyone else. This is the key and the foundation for the public key infrastructure, and also requirements for the public encryption to work properly. So SSH utilizes symmetric encryption in a few different places. During the first initial key exchange process to generate a shared key for symmetrical encryption, a symmetrical encryption will be used. In this stage, both parties produce temporary key pairs and exchange the public key in order to produce the shared secret that will be used to encrypt the session. And in case of SSH key-based authentication, a symmetrical encryption will be used to authenticate a client to a server. So the client creates a key pair, public and private key pair, and uploads the public key to the remote server where it wants to access. That public key will be stored in a file called authorized_keys within the hidden directory, SSH directory, which is inside user's home directory in the remote server. And this file contains the list of public keys, one each line, that are authorized to log into this server. And the server will use public key in this file to encrypt a challenge message to the client. If the client can prove that it was able to decrypt the message, it is confirmed that it owns the associated private key, and the server can initiate the SSH session for the client. So what happens is when server sends challenge message, the client will decrypt it using its own private key and combine the decrypted challenge message with the previously negotiated session ID, which server and client produced using a key exchange algorithm, and generates a hash digest and transmits it back to the server. The server already had the original challenge message, which it sent to this client, and the session ID, which they generated together using key exchange algorithm. So it can also generate a hash digest out of those value and compare it with the hash transmitted by the client. So if it matches, server can confirm that the client must have the private key and it is who it claims to be. Next is hashing. So hashing is a one-way function and is used for the data integrity. You can produce a hash of given data, but you cannot reverse the hash to generate the original data. So when you receive the data, you can apply the same hashing algorithm and generate the hash value and compare it with the transmitted hash value. If it matches, it is confirmed that the data has not been altered during the transmission. So SSH uses hashing technique to ensure the commands that were sent or received by the client and server were not tampered in any way. And this is done using HMAX or hash-based message authentication codes. So as a part of symmetrical encryption negotiation, which we discussed earlier, a message authentication code algorithm is also selected during the initial handshake process. And the algorithm is chosen by working through the client's list of acceptable MAC choices. And the first one out of the list that server also supports will be used. So the MAC itself is sent outside of symmetrically encrypted area as the final part of packet, and which will go to the client side and generate a hash. And if the value matches, then that's how it confirms the commands were not altered. So SSH is established in two different phases. First, generate the session key, and second, authenticate the user. So during the first phase, server and client generate a shared secret key using a key exchange algorithm, either RSA or the variation of Diffie-Hellman algorithm, which both server and client agree on during initial handshake. So when a secret key, also known as a session key or session ID, is generated, client sends finished message encrypted with the session ID, and server also responds back with the finished message encrypted with the same session ID. And now the symmetric connection will be established for the future communication, including the next phase, which is client authentication. If they agree on RSA as a key exchange algorithm, these are the steps takes place to generate a shared secret. So client first makes a TCP connection on port 22, which is a default port for SSH, and provides the protocol version, random string known as client random, and the cipher suites it supports. So server responds back with its chosen cipher suite, along with random string known as server random, and its public key, which client can match with its database of trusted server, which client records inside a known_host file in its home directory. Client then generates a random string known as pre-master secret and encrypt with the server's public key and send it back to the server. So server decrypts the client random string using its private key, and both client and server generate session keys using client random, which was sent by the client, server random, generated by the server and send it to the client, and the pre-master secret, which was generated by the client and sent back to the server. So both client and server should produce the same result, and client sends a finished message that is encrypted with the session key, and server sends a finished message encrypted with the same session key. So secure symmetric encryption achieved, and the handshake is completed and communication continues using the session key. If Diffie-Hellman was used as a key exchange algorithm, instead of client generating a pre-master secret in step 3, here we saw this step, server encrypts client random and server random and its DH parameter with its own private key and send it to the client along with its public key. So this step serves as a digital signature signed by the server, which client can decrypt and verify using the public key that server provided, and can also match the public key in its known host database. For the purpose of digital signing, message can be encrypted with the private key to be decrypted with the associated public key. So instead of client generating a pre-master secret and sharing it to the server, like in RSA, in this case, server and client uses DH parameter to calculate pre-master secret independently, and use this pre-master secret, server random and client random, to generate session ID, same as we did in RSA algorithm. So during the second phase, the user authentication takes place. User authentication can be achieved using username and password. Even though this communication is encrypted using symmetric encryption encrypted with session ID, it is now recommended because of password guessing and other common attacks like brute force attack or dictionary attack. And that is why SSH key authentication is recommended to access remote server. So to summarize, client initiates an SSH connection process to the server. Client and server negotiate to produce session key using a key exchange algorithm. Both encrypt further communication using symmetric encryption and use session ID or session key as an encryption key. Client maintains known host database for the server it wants to connect. Server checks its authorized keys file to check if the client is who it claims to be. And if client can verify its identity, server gives an SSH session to the client. So key pair is created typically by the user using SSH keygen command. Private key stays with the user and only there. You can also use passphrase to protect the private key, while the public key is sent to the server, typically with SSH copy ID utility. And server stores the public key and marks it as authorized keys. And server will now allow access to anyone who can prove they have the corresponding private key. So this is the theory behind SSH, how it works, and how we can use public cryptography strength to secure SSH session when remotely accessing the server. Now let's get into the setup. So I have two Linux machines, one Kali Linux and one Red Hat Enterprise Linux 8. And I'm treating Kali Linux as an SSH server and Red Hat Enterprise Linux as an SSH client. The reason I selected Kali Linux as a SSH server is because by default, SSH is not enabled in Kali Linux for the security reason. And I wanted to show you how to enable it for one time or during the startup and try to do the SSH connection. So ifconfig, the IP of the SSH server is 172.16.10.7. If your SSH server is in public domain, then you will have a public IP address. Now let's get to this client and do SSH. You can simply do IP address and the connection is refused because the SSH is not started. So now let's go back to the server. And you can use sudo systemctl status SSH. So it's inactive. In Kali Linux, SSH is disabled on a startup. So you can enable that, or you can simply start the SSH session for this instance. So you can do sudo systemctl start ssh.service, which will just start the service for this session, for this login. And now it's active. And if you want to enable during the startup, then you have to do systemctl enable ssh.service. And to disable, simply type disable. So now let's go to the client and try to do SSH. You can do SSH with IP address only, but only if you have the same user on both client and the server. So in this case, username, I'm logged in as Umesh on the client side. And if I go onto the server, same user. So in this case, you can simply type. So when we did SSH and the server IP address, it is asking, do you trust this server? So it is giving us a fingerprint of the server's public key. So this is the fingerprint for the server's public key, which we can verify. Let's do no here. And if we go to server and use sudo SSH keygen -l-f and keep the, it was using ECDSA encryption method. So we are going to check the fingerprint of this public key. So this is the public key fingerprint, and this is the exact fingerprint that the server presented on the client side when it tried to create the connection. So now we confirm that this is the same server that we are trying to connect. You can click yes, and also let's say, for example, if your username is different, you just type username with the @ sign. And one thing before we make a connection. So if you do ls-a on this home directory, you do not see .ssh folder here. But now let's go and connect. So it's asking for the fingerprint, which already verified that it is from the server. So if you click yes, then what happens is now the client creates a .ssh folder and creates known_hosts file where it stores a public key for the server. So now this is asking me my password, Umesh user's password on the server side. So let me enter that, and I'm into the server. ifconfig, and IP address is 7, and list. Now I'm into SSH session inside the server. And if I exit out of it, here's the screen, ls-a, you see the SS folder here, and it will have the public key of the server, which is 172.16.10.7, and this is the public key of the server, which we can check by reading to this is the public key. So basically it is saying that on the client side, any server presenting with this IP address and this public key, it is known host, and you can confirm or trust the server. Now, next, what we can do is we can try to disable username and password login to the SSH session. To do that, let's go to the server, and let's go to SSH config file. Here, so password authentication is enabled here, and we are going to disable it by changing option from yes to no. Save. Now sudo systemctl stop SSH service and sudo systemctl start SSH service. Now let's go back to the client and try to make a connection. It should refuse the connection. So permission is denied because it now only allows you to access using public key. And that is what we are going to set up now. So public key is like we discussed in theory. Public key generally is generated on the client side using SSH keygen utility or command. And let's do that. So SSH keygen, and the encryption is ECDSA, which was presented by the server. And if you use RSA, then it's -T RSA. Enter. So now it is asking me where I want to save the file. By default, it goes to the SSH directory inside the home directory of the user, and just enter. And it is asking to enter the passphrase. So this passphrase is used to protect the private key, which I highly recommend. But on this demonstration purpose, let's leave it blank. So enter, no key. Now it generated a public private key pair inside SSH folder. So this is the private key, which you have to keep secret. And this is the public key, which we are going to transfer to the server and ask server to authorize ourselves to log in. So this is a fingerprint for our own public key, which we can generate again. -F, -L, -F. This is the fingerprint. Okay, now let's go and copy this public key to the server using SSH copy ID utility, which we discussed in our presentation slide. And the command is SSH copy ID, a username of the remote server, and the IP of the remote server. So what happens is when we do this command, on the server, there is no SSH folder here. It will create a SSH folder, and under SSH folder, it will create authorized_keys file and copy that public key to this server. Let's go ahead and do that. Permission denied. Oh, the reason is we disabled that password authentication here, and to demonstrate that we should only allow public key authentication. Now let's stop the service, start one more time. Now let's get back to the client. Now it's asking me for the password of the remote server user Umes, and one key is added. So if we go back to the server and list all the hidden file, we'll see that SSH folder here. Under there, we'll see authorized keys, and this is our public key, which we just transmitted using SSH copy ID utility. Now, if I want to make SSH connection to the server, I just simply type SSH and username and the server IP address, and it should give me the SSH session without asking username and password. There you go. Config, no username, no password, simply allowed me to log in because it verified that I'm the owner of the private key, which it has the authorized key stored in its file. And you can simply do this only because it's the same user, it's the same thing. And if SSH copy ID utility is not installed or not available in your client machine, you can also use a secure copy command, SCP, the source file, which is ID underscore public file to the remote machine user, and inside home directory .ssh and stored inside authorized keys file. So you can also do this. Then it will ask for the password and copy the file. Since we already verified and authenticated, it's not asking us because we have our public key private key relationship already established with the server. Now let's say server's private public key got compromised, somebody got access to it, and server changed the public key private key pair. So we'll look into that process. So in case of Kali Linux and Ubuntu, you have to first generate a new key pair and start the SSH service. If you try to start the SSH before generating a key pair, it will give you an error message. But in Red Hat, you can simply remove old key files and restart the SSH service, and it will generate a new key pair automatically. So let's go to folder. So these are the ECDSA private key, ECDSA public key, and RSA public key private key. So let's create a folder. I already have back underscore keys file, so let's move there. Move everything that is to backup keys. Now all the private public keys are moved, and we can use sudo dpkg reconfigure open sh server. It will generate a new key pair. Now we have a new key pair. Now let's get back to the client and try to start SSH connection. We got remote host identification has changed and man in the middle attack warning message. And to fix that, we have to purge the old record from our known host database and establish a new connection with a new public key again. So we can use SSH keygen command to do that, F and now give the location of the file where our known host file is installed, and remove for the IP address 172.16.10.7. So it found one file and deleted and saved as a, so nothing is there, but it created another file called known underscore host old and saved the information there. Now what happens is if we try to connect again to the server, Now it will ask us to verify if this is the new public key. And again, we can do so by going to the client, the server, SSH keygen -l-f, and we're already there. So host _ EC DSA public. Let's try to match it. PB, and here, this is the fingerprint. So now we trust, we just say yes, and now it created a new known_host file, and let us establish a SSH connection. So now we have a new public key, which is the public key that we just regenerated here. Sudo cat this new file, and with fxs4. So this is how you can configure your Linux machine to use username and password for SSH authentication or public key encryption to authenticate client and server. So if you are still using username and password based authentication, I think it's time to change and start using public key cryptography and make your access to the server more secure. So I hope you find this video helpful. You might be already doing this, or if it's new to you, hopefully you will start using SSH key-based authentication system. And if you have any comments or question, you can use the comment box, or if you have any suggestions for the future video, you can write on the comment section. Thank you all for being with me on this video, and hopefully I'll see you in the next video.